popular being Microsoft Word, or you can use the other kinds of open office and all. LaTeX is just another document preparation software. Why then we should move to LaTeX and not use the other softwares? I don't want to give an introduction on that, because after 1 hour, I am sure that all of you will understand why it is a better platform compared to the other popular platforms like Microsoft Word. Well, one thing I must say, that if you are going to write, let's say, a 500 words paragraph in plain English or any other language, then I don't see much of a difference between using LaTeX or say, for example, Microsoft Word, as long as it's just plain English. But the things become very different when the document becomes a much longer one, especially, let's say, someone is writing a thesis or a report or even an academic paper. The reason being that these kind of documents are more professionally produced documents, and there are certain intricacies, like if I'm writing, let's say, a research article, then there are certain things like, apart from the obvious things like titles and the author's name, abstract, etc., etc., there are citations that we produce in those academic articles, bibliography, content generation, graphics that we use. So for all of these, Microsoft Word is rather a clumsy one. I mean, it takes a lot of time. So that's one reason possibly why we would like to use LaTeX, and it will give us a more professional looking output. Okay, so I won't use any other words for introduction. I'm going straight to LaTeX. LaTeX, like any other software, you can use this software on two modes. One is an online mode, the other is offline, that is standalone software, as a standalone software. I'm going to use the online mode for this workshop because that would be much more convenient. So I'm assuming that the participants have already had their what I call it, have their accounts made in the program called Overleaf. So I'm going to share my screen now. If you can see the screen, please tell me. So, is my screen?
Yes, sir, it is visible. Yes, sir, it is visible.
Okay. So this is, I'm simply using my the Explorer, the Google Explorer. I'm going to use Overleaf, as I said. So overleaf.com is the website that we can open. If you have an account there, then you will find the basic page here. As you can see, just hold on. How do I minimize this? Yeah, got it. So this is the Overleaf page. We can create a new project here, as you can see. If at any point I'm not audible or if the screen froze, please inform me. I'll stop. So I'm opening a new project, a blank project. Let's give a name to this project. I'm giving it SPM LaTeX. Great. So this is a new project that we have just created. So if you have done the same thing, you will find something like this has appeared. Are all of us on the same page?
Yes, sir.
So what I want to do now, that you see that there are two panes. First is here, on the left-hand side, where something is written, and on the right-hand side, you see something as a PDF document, something is appearing. Correct? So what I want to do now is to first remove everything that is on the left-hand side. So I'm deleting everything that is there. So it's a blank page now, and I'm using the recompile button at the top, so which gives us a blank page on the right as well. So these are the two pages that you can see. So the left page is for the input page where we will key in whatever we want to write. And the right side pane is the output pane, right? So if you use, say, a document processor like Microsoft Word, you will not find that there are two separate panes like this. You will write where the output comes in, right? So whatever you write, you see that on the screen. So the input and the output panes overlap in, say, software like Microsoft Word. Am I making myself clear? Right. So here, to begin anything, to write anything, LaTeX is a software that works, LaTeX is a software that runs a program. So everything that you write begins with a command. So to begin anything, the first thing that we have to write is a backslash document, curly braces, and we write article, correct? And then again backslash begin, curly braces, document, and then end document. So if you see that these are the three commands that we have already created on the left side pane. So these three tells the program, the tech program, the following things: that we are writing a document which the document type is an article. It's a then the big sorry I made a mistake. It should be not document class. So document class. And then you write begin document and backslash end document. So this backslashes are very important. Backslash means you're writing a command. So LaTeX will read it like that. So every time you put a backslash, means whatever you have written after that should be read as a command for LaTeX. Now within begin document and end document, you can write whatever you want to write. Let me write hello world. And then I press the recompile button. Let's see what happens. So I have a blank document in which hello world has been printed. Is it visible to everyone?
Yes, sir, it is visible.
Right. Yes. Right. So you see that we have just created a document class which has been specified as an article. There are different kinds of document classes that you can use in LaTeX. You can use a report, you can write a book, you can produce a presentation, slides, and so on and so forth, several kinds of document classes. I will be concentrating only on article in today's lecture. The other kinds of document classes are pretty obvious and quite intuitive, so you can try it on your own. There is one document class for presentations of slides, which we call Beamer. And I'm sure that Dr. Jyotima Bhattacharya is going to take a lecture tomorrow. He will be taking care of the beamers. So once you have created a document class, you can write whatever you wish to write within this begin document and end document commands. So backslash begin document is a command that tells LaTeX that whatever is written now on is your main text. And end document, backslash end document says LaTeX that this is where the document ends. Anything that you write after end document, let's say I write something, A, B, C, D, whatever, and then I recompile, that's not printed. Anything that has been written after end document is not considered as part of the document. If I instead write it here, and again recompile, you see that it has been written down. Okay, so I need some text to make it look, I mean, effective. So I am going to generate some random text from internet. So what we are going to do, I'm going to use the Lipsum software. So Lipsum, you can use your internet editor to get this. So Lorem Ipsum is the random text generator. So I'm just going to generate some random text. I'm going to use this. I'm going to get 5 paragraphs of random text for our purpose. So see, this has created 9 paragraphs of random text. I'm just going to copy. I hope it works. So now I'm going to paste it inside the begin document and end document. Yeah, so it is there. Of course, you can see that there are red marks because these are random words. These are actually not words. So the dictionary software inbuilt in Overleaf says that these are spelling mistakes. Ignore those red dots and we just recompile things and see what happens. So you see that there is a longish document that we have just created. So this is the main text of our today's exercise. Now I want to write a paper. So in a paper, you can understand there could be different sections, subsections, everything. It should look good. So let's distribute this text in different sections and subsections and see how do we do that. So again, there are command lines to instruct LaTeX that there should create some sections, subsections. So what we do is we again use a command called \section. So if you're using say Overleaf, then you see that there is a drop down box that is coming, which is giving you all kinds of options that you have. It predicts what you are going to do. So I'm going to use a section command here. So I'm writing a section. Let's say it's the first section. I call it introduction. So introduction. So introduction is the first section, and then I use another section. So again, section after some time. Section. This is the first section. This is the first section. Correct? Let's recompile. See what happened. Oh, see, it has seen that you have given a command that you have introduced a section, which is the title of that section is introduction. So it has given it as the first section with introduction. The number determines the section number. And then your second section is titled as this is the first section. You can change it. And here is this is your first section. Exactly the way you have written. So LaTeX is understanding where to start a section, where to stop a section. Because you have not stopped the section, that's why it has not stopped the second section. That's the first section. This, the one that you have separated as the first section. So it goes on to the end. But your first section actually is titled as introduction, and it ends exactly where the second section begins. If I want to create a subsection somewhere, you can write somewhere here. Let's say I create a subsection. So subsection, just write subsection and it will give you a drop down box. Just write subsection. This is a subsection. This is a subsection. That's the subsection of this. So recompile again. See, it gives you 2.1 as a subsection of this section. You don't have to bother about the desktop editing and all. It gives you a professional looking document, and you can go on like this. You want a subsection, you want a subsection, you can just write, I want a subsection somewhere here. So let me create a subsection. Sub, again, it comes. A subsection. You can predict what would happen. It will come as 2.1.1 subsection. If I recompile, and we're recompiling, let's see what happens. Yes, it is coming as 2.1.1 as a subsection. You can change the title, whatever you wish to give that title of that subsection, and so on and so forth. Let's conclude our paper. So I write here section, and give the title of that section as conclusion. It has come. Great. So you can write your paper in dividing it in different sections, subsection. You can go up to subsection. LaTeX default doesn't allow us to go beyond subsection, of course, which is of course generally not required. But if you wish to go beyond this, then there are other packages that one has to install, and you can go beyond subsection as well. But yeah. So what else do I want to do? Suppose I want to insert a table. So I need to create a table in my document. So what do I do here is, for everything, for tables, for graphics, for let's say for mathematical notations, equations, there are different environments that we use in LaTeX. So you have to, if you are going to insert a LaTeX, if you are going to insert a table, then you have to create a tabular environment in this document. And let's say again, it starts with something like a backslash begin table, and then end table. So let me just create begin table. So I'm just creating a simple table. So once I write this begin table, see, Overleaf is giving me the whole command line. Some softwares actually give you this kind of options that will give you the whole command line. Otherwise, you have to write it on your own. Hardly matters. See, I'll just describe how it works. So this begin tabular is the beginning of our table. And the end tabular here is the end of our table. Whereas towards the beginning, when we write a begin table, end table, that's the beginning and the end of the environment. So just focus on this part of the commands, begin tabular, end tabular. You see that here are two C's inside a curly braces. It says that it tells LaTeX about the nature of your table. It says that your table would be one of two columns. So this this vertical line tells us how many columns we are going to produce. So right now it is a table with 2 columns. If I want to increase the number of columns, I can just key in another one, and that would make my table a 3-column table. The C here is a command that says that whatever I write in a cell, it would be at the center. It's the alignment of the text. So instead of C, you can actually write an L here, which means whatever you write in the first column would be left aligned. So let's say I create a table like this with 3 columns. Then this is the place where your actual table is going to be produced. These ands that you see here, okay, I must at this point tell you something, that there are certain keyboard keys that are considered as special characters in LaTeX. Those are considered special character because if you just because those are also treated as commands, and here is actually a command. So I'll come to this part in a few minutes, but right now just let me create this table and understand that these ands are basically partition of different cells. So towards the left of it, I have 3 columns, right? I've just said that my table has 3 columns. So towards the left of this and sign, I write, let's say, name. And towards the right of this and, I write, let's say, age. And I have 3 columns, so I have to use another and here to partition the second column from the third column. And I write, let's say, height. So I'm basically trying to create a table of students with their age and height. Then you write the name. Name is, let's say, A. Age is, let's say, 15. And again, I have to insert an and. This is the second row of that table that I'm now doing. The first row is this, if you read it. And the second row would be A, 15. And then the height of that student, let's say, is whatever, 4.5. So this is right now a table with 2 rows and 3 columns. Let's see, recompile and see what happens. So do I have the table? Yes, see here is a neat table that has been produced. So you can do many things with this table. If I wish, I want to increase the number of rows. So every time you go to the new row, at the end of the previous row, you put 2 backslashes, which means you are going to the new row now. Now I write B and let's say 16 and 5. That's the new row. I recompile here. What would happen is a new row would appear with the name B, age, and height. See that the names have been aligned towards the left of the table because you have given this left alignment command here. And the other 2 columns have everything centrally aligned because that has been written. You can, if I change it to, let's say, the C to R, obviously you can understand that means I am asking LaTeX to align this, whatever I write in this column, to the right of it. Let's see. Yeah. See, these numbers have right aligned. So these are simple things. Whichever way you wish to use, you use it. What happens if I remove these 2 backslashes that we have introduced? If I remove these backslashes, LaTeX will not understand that you have moved to a new row. So this should give you an error. So let us recompile after removing this. See, there is a red mark on my left-hand side pane. And this is saying that extra alignment tabs has been changed. So you see, things have changed. My table that have been produced has been jumbled up. And LaTeX has never realized that from 4.5 to B, a new row has been introduced. It is producing 4.5 and B on the same. So that's the kind of intuitive things. It's a programming and it's very intuitive, uh, very logical. So you can try it on your own. You can do many things with these. If you want to introduce more columns, you can just introduce more columns here at the beginning. And if you want to introduce new rows, you can just go on introducing new rows. If I want my table to look a little more, decent, I might want a horizontal line to separate this first row from the other rows. So you can use it. You can use a H line, which is basically meaning horizontal line, HLINE. And it should produce a small line and make our table look a little more decent. What happened? It did not. Let me do it again. No, it's not. Something is wrong. Maybe I have done it wrongly. Let's see now. Yeah, sorry. So I have, these are kind of mistakes that we make. Hline is the command that would produce a horizontal line, but I have written it before these double backslashes. That means before the row has ended, I have given the command. That's why the problem was happening. So after the backslash, if you put this hline command, that means that the row has ended. Now you create a horizontal line and then the new rows comes in. So that's how things are. Am I making things clear to everyone?
Yes, sir. It's very
Okay.
interesting.
Okay, thank you.
Yeah.
Okay, so this is a very simple table, and you see that in the document, the table has been produced at the center. The whole table has been produced at the center, and for that you have used the centering commands. So this backslash centering, it has been I have not typed it. The software has predicted that I want it to be at the center, but I may not actually want it at the center. So if I delete this and then recompile, then the default table should come to the left. Yeah, the default table comes at the left of it. But that would not be a very decent one. So sometimes we want things to be at the center. So centering, I'm just using again. You can do another thing as well. You can use another command. I'm just taking the advantage of these mistakes. You can use a begin center, end center kind of an environment. So I'm just going to write backslash begin center. So it should come here, begin center, and it has created an end center. Every time you start a command with a begin, the LaTeX automatically thinks that there should be an end of that command. So it has created this. I want this end center part to be at the end of my environment. So let me now recompile. Oh, it's not. It's not. It's not working. So it's not working because I'm trying to create one environment inside the other one. So let's not do it like this. Let's not do it like this. I come back to this later. So just centering should do. Yeah. What happens if I want to? Okay, now let me come back to this and thing. So as in the process, you have seen this that this notation and has not been produced here in the output table. So which means the LaTeX has read these ands as commands. So there are certain commands, there are certain keyboard characters which are treated as commands in LaTeX. So I'm just going to write at the beginning what are those. So let me write it here. So there are some which has special um, these are following. So what are those commands? Let's say backslash. Backslash is a command that you can see on your keyboard right above the enter or return key. So you can see that backslash has been used as to denote that there is a command that we are writing, right? So backslash itself is a uh, command and cannot be produced by simply typing. Similarly, let's say hash. Hash is, where is it hash? 3. Yeah, hash. This is a command. Similarly, dollar sign, that is a command. Percentage sign is a command. So if you want to write, if I let's say if I want to write some, okay, I'll come to that later. Let me just finish whatever I'm doing. What else? Curly braces. So you see, every time you write a begin document, end document, the document is written inside curly braces. So curly braces is part of the command. So you do, so curly braces, these two, these are separate identities, and they are basically special characters. Then, and of course, uh, then is this. And what else? Ah, hat. So these are some of the special characters. There are a few more. I just don't remember immediately what are. Oh, backslash, of course. Backslash. So these are, if you can see, I'm just trying to enlarge my fonts. So these are some special characters along with backslash, this one, which are itself commands. And if you want to produce them as and print them, then you have to apply a backslash here, to apply a backslash there, a backslash here. So every time you put a backslash, that means that's a command. So if I, instead of write, let me just tell you something, show you something. So in the first line, let's say A, B, C, D, E. I'm going to write something here. So what is 10% of 100? So I'm asking a question. So I want to print this sentence. What is 10% of 100? Compile. Let's see. You see that it has not been printed. What has been printed? What is 10? That has been printed. Can you see? In the first line, what is 10? That part has been printed, but whatever is there after 10, that has not been printed on the same line. So that's because this percentage here is a particular command that tells LaTeX that whatever is written after this percentage sign should be omitted in that particular line of text. So the LaTeX is reading it as you have asked LaTeX to print what is 10 and then you have placed a percentage sign. That means on the same line, whatever has been written should not be printed. So, but that's not what we want. We want the whole line to be printed. So I need to print this percentage sign. In order to print that percentage sign, you have to put a backslash just behind the percentage sign. And then you recompile. It should give you the whole sentence. Yeah. If you can see, it says that what is 10% of 100? So these special characters, to print those special characters, we need to place a backslash behind them. But not all of them would work in that particular way because these would work for, let's say, for hash, for dollar, for percentage, it would work. Then I put a backslash here, I put a backslash there, and backslash. This is backslash. But for this hat sign, backslash would not simply work. I have to also put a curly braces. And then if I recompile, well, let's see what happens. Now they have printed these commands, but the backslash itself at the end, here, the backslash itself has not been printed because we have not given any command. Backslash itself is a command, but backslash, to print the backslash, you need to write it as BACKSLA. So whole thing, write backslash, 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 and then recompile. It should create a backslash here. Yes. Are things clear?
Yes, sir. Very much clear.
So these are the special characters. These are some things that we have to take care of. Other than that, everything else in the keyboard can be directly printed. Okay, so now I'm going back to the table. We have created a table. Suppose I want to create a graphics. So I want to include a graph or a picture in my document. Okay, before that, let me just make my document a little more decent. So we want to create our paper and I want to create a title for my paper. So backslash title. So, okay. See, before this begin document command, this whole section is called the preamble of LaTeX. The preamble part includes all the commands that should be operative over the whole of the document. And between this begin document and the end document command that we have used here, at the end, you have an end document. So between begin document and end document, this is the body of the text, the body of your LaTeX document. So in the preamble, which is this document class article is a part of that preamble. That means I'm just going to use something like, what do I call it? Title, backslash title, TITL. Then inside the curly braces, you can write the title of your paper. Let's say Introduction to LaTeX. Recompile. Did not produce anything. But LaTeX knows that this document has a title, which is Introduction to LaTeX, but you have not given the command to print it yet. So after begin document, I have to write make title, \make title. LaTeX is going to help you to find the commands. So recompile again after writing make title. Yeah, now it has created the introduction to LaTeX. So you can, for LaTeX, we have a particular logo for LaTeX, and you can use that. And after make title, okay, you can also use the author's name here. So author, \author, and just write the author's name, my name. Recompile, and you can get a decent looking document in this way. Okay, now coming back to graphics. In order to include graphics, we have to use a graphics environment. But in order to use the graphics environment, we have to use some packages. So in the preamble, we need to include certain packages. So for that, the command that we are going to use, this is a very useful thing, and you have to use several kinds of packages for the purpose of writing papers, books, articles, and whatever. So use package. And there are different kinds of use packages that you would be interested in. For using graphics, you just use a use package called graphics, PHICX. I'm going to use a few more use packages in order to save some time. One would be, because we are going to use some mathematics, it's very useful that we use AMS Math, AMS fonts, and AMS symbols. So use package, inside your bracket, you just have AMS Math, AMS fonts, and I would like to also have AMS symbols. So these are the packages that we want our LaTeX to use. Yeah, so now we are ready. So let me just insert a graphic here. Now, in order to do that, you need to first have a picture which you want to insert. So what we're going to do is, here we have to upload a picture to Overleaf. If you are using a standalone software which is not Overleaf, that means if you install a software in your computer and do it, then just remember that the main document should be saved in the same folder where you are going to save this picture. So now I'm going to upload some pictures which I have here in my computer. So here you have this upload button, upload. It will ask select from your computer. So I'm asking my computer. Okay, where is it? I have desktop. So here are some pictures that I have already. So I'm just going to upload these two pictures, which I intend to use. So these are all PNG files. LaTeX supports PNG, JPEG, PDF, these kind of files. GIF will not be supported, by the way, but most of us use generally JPEG and PNG, so it's not a problem. Now, if I want to include graphics, then just write it like, let's say, \begin again. Begin, what should we use? We use figure, begin figure, right? If I have a begin figure, I should have an end figure. So I'm doing it manually once, otherwise the software also gives you all kinds of options. You can use that, IGURE. So this is where I want my figure to be there. Now I want the figure to be what? Include graphics. Now, here between this begin figure and end figure. Begin figure and end figure creates the environment, tells LaTeX that here is a graphics environment. And there, then you ask LaTeX specifically to include a graphics. For that, the command that we use is include graphics. The drop down menu already tells you. If I've just written in and it is already giving me include graphics command, you can write it or you can type the whole thing. It's always beneficial to type the whole thing, because at some point you will understand that not all softwares will give you these drop down options. There you need to know the commands, and if you type the commands, then you will also remember the commands. Now I'm just telling LaTeX hereby that I need to include a graphics here, and in the curly braces I need to tell the file name of that document. So let's see, because I have already uploaded these two documents here, what is called ICPNG and network PNG. So in the drop down menu, it is giving me these options. So let me just recompile, see what happens. TDT include. Oh yes, it has included the picture, but as you can see, the picture is too large for my document. So I need to scale it down. So here inside this square bracket, you just write the scale, SCALE, scale equal to how much do this, you can roughly understand that this picture is too large. So I might be needing 0.2%. So 0.2. 1 scale equals 1 means the dimensions will be as it is. I want just 0.2 of it. So 0.5 means it will scale it to half. 0.2 means further short it, squeezing the thing. Now recompile. Let's see how it looks now. Oh, it looks nice. So now it looks decent. I want, what should I do if I want to center this? I just again write centering, \centering. And that should tell LaTeX that I want this document, this picture to be at the center of my page. Okay. So you can do it in this particular way. One thing now you should notice that where exactly have I located this figure? Here is a subsection, as you can see. So, and then the first paragraph, after that, I have inserted the picture, and then the next thing goes on. Then there is a table and all. But when I see the document, you see uh, it is not placed exactly where you wanted it to be placed. It has just the LaTeX has decided to put this graphics just above the subsection of the document. Where is the subsection? Here is the subsection. So you wanted, let's say, to show the world this particular picture after reading up to this level, but it has placed the picture actually above the subsection. That is because graphics is considered as a float. A float is a particular kind of entities which LaTeX thinks that would place that float in entities wherever it finds place. So it's trying to be very efficient. The software is trying to be efficient, and therefore it has placed it there. But if I don't want it to be placed exactly at that place, I can use a use package here. Use package and write it as float. So use package float would ask LaTeX to print the picture exactly where you want to print. But for that, after begin figure, you have to use one more command, which is, let's say, it's bracket H, capital H. So, and now you, if I recompile, you would find that the position of the picture would change and it would be exactly located somewhere. Now, the time is running short, so I'm just going to go for bibliography, which is an essential part of this exercise. So, in articles, we sometimes want citations. So, suppose I want this document to have some citations. So, I want to, let's say, so I'm going to use Scholar, Google Scholar. So, in Google Scholar, I ask for LaTeX tutorials or guides. What do I find? Okay, there are several LaTeX guides which would help you, and I want them to be cited. So in order to do that, what we have to do is we have to create a bibtex file, a bib file. So here, towards the left of the pane, you see the new file here option. So create a new file. It would by default say name.tex, but we want it as, let's say I want it as ref, and the file type should be bib. So I'm creating a bib file, bib file. A bib file is a bibtex file where the bibliographies are collected, and the name of that bib file is, let us give it is ref. So I'm creating it, and here is my ref bib file, as you can see. Now again, I am going to the Google Scholar, and let's find some good books. Well, I don't know which one is good. Well, this is a very good book. This book, LaTeX User Guide Reference Manual, this is created by Leslie Lamport, who has actually, who has created LaTeX. So I want to use that book. So go to the citation. Here is a citation command here. So citation, and there you will find that at the bottom there is a bibtex button. So click the bibtex button, and this is the bibtex description of this book. So just copy this part, whatever has been written. Control C, and go to your ref b file, paste it there. Keep it just like that. Go to again your Google Scholar, close this, and if I want, say, some other book, I want something not from LaTeX Guide, I want something from, say, microeconomics. So micro steering. Okay, fine. Let's see what Google can say. Okay, here are some books here. Which book do I? Okay, here is a Nicholson's Night. So I want these as a reference. So citation. So the cite command, bibtex should give me the description of this. Just copy this, Control C, paste it again in your B file, and so on and so forth. As many references as you need, you can just collect them there, and then you go back to your original main text. Here, in order to insert the bibliography, I need to use one command here, which is to tell LaTeX that I'm going to use a bibliography. So backslash bibliography style. So you can see the bibliography style command here. So just write bibliography style. I am going to use, there are several bibliography styles. Different journals use different kinds of, so I'm going to use the Elsevier bibliography. So which is ELS, sorry. Yeah, I'm just writing ELS article. Numbered NUM. So that's the bibliography style I'm going to use. And at the end of the document, okay, before I go, I need to cite things. So suppose in the first introduction section, we write that C Leslie Lamp, L Lamp, and so I want to refer to the Leslie Lamport book here. So what I write is here is a command here, \cite, CITE, and that would give you have already created your refbev file. So the LaTeX knows that these are the two references that you have. So you just click that. So if you just go back again to your bbref file, you see that it has been written like this. It's a book. The name of this particular reference is given as Lamport 1996 LaTeX. The whole title of the book is written here, and the author's name there, years, publisher, everything there. So it's a collection of all the information. Now go to your main text again. You have just cited this book, and let me just recompile things. Okay. No. Before I recompile, I just have to. If I recompile, what would happen? Should it create a bibliography? The answer is no, because I have not asked it to create a bibliography. Everything needs to be asked. It's that way very stupid kind of a software. It doesn't understand anything on its own. So I have to write here bibliography. At the before we end the document, you just write bibliography \bibliography. And then inside the bracket, of course, you have to give the name of your bib file, ref. Now, if I recompile, it should come up with a nice bibliography. Yeah, see, references and all. You can have multiple references. Let me just copy a few from my other projects. So I have some projects here. Ref file. Control A, Control C, and I'll go back to my. This is the project that we are doing. Just paste all these bibliographies here. Now I go to my main text. Now you give wherever you want to use a citation, just \cite, and all the bibliographies. I have now used many because I have just pasted a lot of bibliographies here. So I'm just so I've used multiple bibliographies. I'm going to use one more here. Cite, let's say Indian LaTeX. So now I recompile again. So what would happen? See, there are, see, if I just enlarge this, see, this is the first citation that we have used. Then there are, okay, I have to recompile, I think, again. Yeah, you have to recompile twice to have your bibliography ready. So I have used 4 citations, so 4 of them has come up in the order of their appearance with number. This is the way Elsevier does it. If you want to have a different style, you just have to change the bibliography style here at the preamble, right? If you change the bibliography style, you can get different styles. And please understand that there are several commands that you can use, and one cannot remember everything. Google is your friend. So whenever you have difficulty finding a command, you just Google it and you should be able to find. Now there are a few more things that I want to do, and we'll stop there. So this is wonderful right now. I just want to create a table of content. So after this begin document part, you have already created make title. You just write a command called uh, table of contents. Really of contents. Not every, as you can see, there is no drop down menu here. Not every commands are there in the drop down menu. Table of contents. Uh, you can have list of figures. You can have list of tables. Everything. So list of tables. If I want a list of tables, backslash list of tables. If you want list of figures, backslash list of figures. Sorry, list of figures. Recompile things. Let's see what happens. Yeah. So you have now created a table. I just want these list of figures, list of tables to be on a separate page. So new page, backslash new page. That should make your document a little more decent. Yeah. See. So that's your new document now with all the bibliographies and all. If you want hyper references, hyperlinks, then there is a use package again, backslash use package hyperref, hyperref, yeah. And again, compile. What should happen is that your documents should be now having hyper-referenced. Yeah. So now you see, if I click, I go to the, and again, that should also work for the references. The references are now marked as hyper-references. So you can go to the reference that way. This, of course, makes things a little look little ugly. If you want to make things a little more decent, I can just insert square bracket and write hide links. So how much time do I have?
सर आप कर सकते हैं, आप और भी ले सकते हैं 10-15 minutes.
I'll just take 5 more minutes because that will
we are stuck. Your finding is very interesting, so we are stuck.
5 minutes. So you can do all kinds of things. The options are literally limitless because LaTeX is an open source software. It's a free software. It's an open source software. That means everyone can produce their own packages, and people are actually creating their own packages and commands every day. So the options are limitless with LaTeX. So you just use these hide links here. That would make your document look a little more decent. But the links are still hyperlinked. So as you can see, the moment you go there. So all kinds of things you can do. One more thing I want to tell you is that if you want, sometimes you want to produce a list of things. So I have not introduced that. Let me just do that now. So I want to create a list of items. So for example, if I, so there are teachers here. So if you want to create a question paper, there are first question, second question. So that's a list. Several ways, several times we want lists to be produced. List also has an environment. It's called the list environment. And it can be done in different ways. Let's say I want to produce a list. I do it like this. Begin, backslash, begin, enumerate. So backslash begin enumerate. Enumerate inside the curly braces. Enumerate. So it is already giving me enumerate. I end it. So every time you begin something, you end that environment. So we have created a begin enumerate environment. It ended with the end enumerate. Inside that, if there will be several items that I can write. So I can write that sun rises in the east. Sun rises in the east. Then I want an item. These backslash items are commands. It says that these are the different items that were created. What time is it? Is another sentence I'm just writing. What time it? Then again, item. 2 and 2. I'm just using random sentences. These are sentences that I use in my logic classes. So these are the ones that are coming automatically. So again, so I've just created an enumerate environment, list environment. It should create a list of things exactly where you have. So it is just above subsection. This is a subsection section, right? So see here, it has created a list of things with numbers. If you want, you can do it. I'm just copy pasting the same thing. And instead of enumerate, I say itemize. Itemize. If you have a begin itemize, you should have an end itemize. Again, recompile. It would give you the same list, but with bullet forms. If you want to have alphabets, then there is a command for that. So I really don't have time for this, but you can play with it. Now that you know how to do it, you can play with it. You can change the commands. You can see what happens. You can and understand that Google is your friend. Google is your friend. Every time you need to know a command, you just type it in Google. There either Google or the Overleaf also has a reference section which gives you the tutorial kind of a thing, a guideline for commands. Otherwise, you can go to the Stack Exchange websites where every LaTeX user shares their experiences, gives shares commands. So you can write a problem there in Stack Exchange and you can get. So if suppose I want to know the LaTeX command for maths. Oh, I have forgot to give you the mathematical expressions. So if you want to give LaTeX command for math, you see there are lots of options that are coming in. Josna, I'll just take 5 more minutes because one one example for mathematical expressions.
We are following you. You carry
Yeah.
on.
So no, because time is running out. So here I want to use a mathematical equations. It's very easy. First of all, you have to use the packages which we already have. So use package AMS math I have already used. So LaTeX can handle mathematics now. I want to write an equation here. So in running in the text. So if you want to write an equation, you have to start with a dollar sign and end with a dollar sign. So dollar signs are used for mathematical environment. So I'm just writing dollar and inside that it's so let's write like a plus b whole square, a plus b whole square. The hat sign is for squaring. So a plus b whole square is equal to a square, a hat square. That means plus b hat square plus 2ab. And it ends with a dollar. So you see the thing starts with a dollar, ends with a dollar. That means it's the LaTeX understands that this is a mathematical expression, and you compile it. It should where is it? It's after the difficulties. Where have I? Yeah, here. So you see, the mathematical expression has been written as a running part of the text. Suppose I want this. So where is my equation? Yeah, here is my equation here. So here is my equation. A plus b whole square is a square minus a square plus b square minus 2ab. Oh, I have, sorry, it should be equal to, it should be equal to, yeah. I want to write it separately, not running in the text, but separately in the next line. So that the mathematical expression can be emphasized. Then write the same expression inside double dollars. So $2 to begin with, $2 to end with. And if you recompile, you would find that this expression here would be written in a separate line. Yeah. So it looks better now. There are all kinds of equations that we can write. Suppose what can I write? Let me create a sometimes we want to write, say, equations, set of equations, not a single equation, but a set of equations. That means, and they need to be aligned as well. They need to be aligned, they need to be numbered and all. So what we do is you write B, write an array environment. So you write something like, okay, begin align, ALIGN. It should create an end align. And here, write whatever. You write, let's say, x plus y is equal to a plus b plus c. Then that is equal to, so sometimes in a proof, we keep on writing things which should be equal to, it is equal to c plus d plus e. I'm just randomly writing things, so forth. And I want LaTeX to, sorry, C plus, where's my D? Yeah, D. I want LaTeX to produce this such that these equal to signs are aligned on the same vertical. I mean, they're aligned vertically so that there is a symmetry between the left-hand side of the equation and the right-hand side of the equation. So just like what we did in case of a table, you just separate it with an and sign before the equal to signs. So that means if I recompile, things will be visible, I guess, if I'm not made any mistake. Yeah, see. So if you do that, then you get an array of equation, which looks better and okay. And it is numbered as well. Why is this number 3 coming? There is no equation because I have made a mistake here. I have used these double backslashes to indicate that I am going to the moving to the next line. That's why it thought that there is a third row as well. Now it should remove this number 3. Yeah. So this is the thing. So that's how you can create all kinds of mathematical expressions. All kinds of notations are there available. Just play with the notations. If you don't find a notation, don't know a notation, just type for it in Google. It will tell you. But the most of the commands are very intuitive. For example, if I want a square root, what do? I just write backslash sqrt. That's the command for the square root. And whatever would be after the square root, that should be placed inside a curly braces. And you recompile, it should give you a root over of b here. So these are the intuitive things that you can do. Just one basic thing that I forgot to mention. While we write in LaTeX, multiple spaces are not counted as multiple spaces. Whether you put one space or multiple spaces, LaTeX will read it as single space. So that's the beauty of LaTeX. Whereas in Word, it will be considered as multiple spaces. So if you mistakenly If you have placed more spaces, that's fine. If you put just one enter at the end of a line to break it, LaTeX will not read it as a separate paragraph. So if you want to change from one paragraph to other paragraph, suppose here I want to, so here I want to, so after this full stop, let's say I want to start a new paragraph. So one enter would put this in the new paragraph in my left hand pane. But if you compile things, you will find that it has not been uh, considered as a new paragraph. So this is my first section, so it should go here somewhere. Yeah, see, the paragraph has not been broken. So in order to break to a new paragraph, a double enter is required. A double enter, and then you recompile, and you'll find that here is a change in paragraph. These are a few things that basics that one should know. So spaces, multiple spaces do not count, and double enter is what you need to go to a new paragraph. You can change the paragraph indentation, or here there is an indentation that you can see. You can change all of that with a suitable command that you can write at your preamble. You can just write, let's say, what do I write here? So let's say you want it to be okay. One more package should be important. Just because Gemoy will be doing tomorrow, so I just need to do the basics. So use package geometry. Geometry is a very interesting package which would allow you to tell LaTeX about the margins and all. Sometimes that is very important, because you see, this is the default margin that LaTeX is using. Sometimes we want LaTeX to be, we want to change margins according to our wish. So here you can write it as top equal to, let's say 0.5. It has become dark here. So top is, let's say, how much do I need? Let's say 0.5 IN. 0.5 IN means 0.5 inches. You can use either inches or centimeter to let, then comma. You want the left to be, or to the right to be, sorry, equal to, you want to reduce the margin, so you just right margin should be 0.3, let's say, and run it. It should change the top margin and the right margin. See, it has changed, but I have given two. I made the margin too narrow, so let me just put in a little more, 0.6 maybe. I will compile. Yeah, that should do 1. Sorry, 1 centimeter. Recompile. Yeah. See, you can play with LaTeX in whichever way you wish, but that way it gives you a decent looking document. The best part is you don't have to bother about the content creation. You don't have to bother about the bibliography, which is a big headache for all of us whenever we write papers. And changing bibliography styles is a nightmare for anyone who is writing a PhD thesis. Content creation is problematic because every time you edit something somewhere in the document, the whole document gets messed up, so the page numbering changes, etc. So content creation has to be automated, and LaTeX does a wonderful thing there. You can have a list of tables, list of figures as you wish. So I guess that should be all for today's lecture. Is there any questions?
Thank you so much, sir. It was an amazing session. I'm sure all of us have learned something new and valuable from it. Sir, there are a few questions in the chat box. I will just read them out for you. So the first question is, does LaTeX provide suggestions while writing the command as in R software?
It depends on the software that you are using. See, I should mention that Overleaf, as we see, it gives you suggestions. It gives you, I mean, suggestions in the form of what command you are going to use. So if you of course have to start the command. You need to know the command. If you don't know the command, then the best way is to find it in Google. Just Google anything that you have in mind, and you will find the right answer. It's so intuitive, so easy. If you just start the command, then Overleaf will give you some suggestions. But if you are not using Overleaf, if you are using some other softwares, then not all softwares will give you suggestions. That's why I'm saying that it is essential that you actually know the command. It is for not only for LaTeX, whether you use R, even in R, there are suggestions I can understand, but you need to know the commands yourself. That's very basic to become a programmer, right? Yeah, that's my suggestion. Yes.
And sir, the second question is, do suggestions means the error detail?
Error details, yes. If you make a mistake in the command line, it will either give you an error or tell you what kind of error. Sometimes if you see the document that we have just created, there are often you will find that lines will be marked as red, highlighted as red. Whenever it is highlighted as red, LaTeX is thinking that there may be some mistake from my side while I'm writing the command. But sometimes, even if there is some mistake, it can still be able to produce the outcome. Sometimes it will not be able to. And in that time, it will say there is an error, fatal error. So you need to change your commands or something. So that, and it will give you some suggestions or what kind of command that you can use. But that is specific to the program that you are going to use. Overleaf is a program that will give you suggestions. Not all programs will give you these kind of suggestions. And if you want to not use Overleaf, see, there is a obvious problem with Overleaf. It's an internet-based software, so you need you need to be online all the time. I write my paper sometimes when I'm traveling in a train. So you don't have a running internet. So that's why it is essential that you have a